Today's lesson is about factors, prime factors, prime factorization, and standard prime factorization. Um, as you know, 6 can be written as 1 times 6, 2 times 3. Therefore, we say 1, 2, 3, and 6 are factors of 6. Or we can say 6 has 4 factors. Now consider 5. 5 can be written as 1 times 5. There is no other way that you can break down 5. So therefore 5 has 2 factors. So 1 and 5 are the only factors of 5. Okay, all numbers like 6 that they have 3 factors or more are called composite numbers. All numbers like 5 that they have exactly 2 factors, they're called prime numbers. So a composite number has 3 or more factors. Prime numbers so a prime number has exactly 2 factors. So what about 1? 1 is neither composite nor prime because 1 has exactly 1 factor. So I'm going to write it here because it's very important, and sometimes, a lot of kids are confused about it. So 1 is neither composite nor prime. It's good to know that we have one even prime number. So 2 is prime. Why? Because 2 has 2 factors only. So 2 has 2 factors. 1 and 2. This is why 2 satisfies the definition of prime numbers, right? But I'm going to explain why no other even number can be prime. So isn't it obvious that every even number has 3 factors? Itself, 1, and 2, because every even number is divisible by 2. Therefore, every even number other than 2 has at least 3 factors. So 2 is the only even prime number. I suggest you to write down for yourself all prime numbers from, for example, 1 to 50. It's a good experience to know prime numbers. I'm going to quickly write, for example, all prime numbers less than 20. Starts at 2, 3, 5, 7, 11, 13, 17, and 19. So now that you are clear about the difference between composite numbers and prime numbers, let's try to break down all numbers to their prime factors. 24. I want to know 24 is made of how many and what prime numbers. So 24 can be written as like 6 times 4 or 3 times 8 or 2 times 12. So it doesn't matter which two numbers you start with. The final answer would be the same. So I'm going to start with 4 and 6. 4 and 6 are not prime. This is why we'll continue the process of breaking them down. 4 is 2 times 2 and both are prime. This is why I'm going to encircle both. 6 is 2 times 3. Now we are done because all these encircled numbers are prime. So therefore 24 can be written as the product of all numbers in the circles. So 24 can be written as 2 times 2 times 2 times 3. If you doubt, you can multiply these numbers to see if we get 24 or not. I'm going to do it quickly. So 2 times 2 is 4. 2 times 3 is 6, and obviously 4 times 6 is 24. It means we are correct. So we have another representation. We just said that 24 can be written as 2 times 2 times 2 times 3. There are 3 2's that we can put them together and use the exponents to express this as 2 to the power of 3 times 3. This one is called prime factorization of 24. This is called standard, the standard prime factorization (24). Let's have another example to practice more. Let's say 120. I'm going to find prime factorization of 120 and the standard prime factorization. There are, as I said before, there are many ways to write 120 as the product of two numbers, but I think the easiest one might be this. So 12 is 2 times 6. 2 is prime. I'm going to encircle. 2, 3. And 10 is 2 times 5. So I'm going to write them from left to right, not to forget any of those. Therefore 120 can be written as 2 times 2 times 3 times 2 times 5. This is the prime factorization. And if you use the exponents, there are how many 2's? There are 1, 2, 3 2's. Therefore, we can write it as 2 to the power of 3 times 3 times 5. And this is standard prime factorization of 120. You may wonder that why we need to know about standard prime factorization or prime factorization. I'm going to share with you one of very interesting applications of the standard prime factorization. So I am going to find the number of factors of 36. Even though 36 is a very small number, but it's not very easy. Sometimes, we miss some of them, right? So 36 can be written as 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So, okay, I wrote the all possible products of 36. Therefore, the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. So if you count these numbers, there are 9 of them. So 36 has 9 factors. So this method is not very efficient. Why not? Because it takes a while. It takes forever sometimes. What if question is not about 36? What if it's about 1,200? Can we afford to write all those products one by one? So this is why this method is not efficient, and we need to find another method that can find the number of factors without writing all factors one by one. I'm going to explain this method here. So we learned here that 36 has 9 factors. Now I'm going to use the standard prime factorization to find same thing, the number of factors of 36. Okay, 36 can be written as 6 times 6, 2 times 3, 2 times 3. Therefore, 36 can be written as 2 times 3 times 2 times 3, or by applying the exponents, it's going to be this times this. Now, this is what I suggest you. 2 and 3 are called bases, right? And 2 and these 2 are called exponents. What I suggest to you is that we write the exponents here. Then we add 1 to each exponent and write them underneath. So it becomes 3. This one also becomes 3. And then we multiply these two numbers and the answer is 9. The same that we got here. So 9 is the number of factors of 36. Did I write all factors in the second method? No. I just used standard prime factorization to figure out what is the number of factors of 36. I'm going to give you another example. Let's say 480, and I want to know the number of factors of 480. So let's do the standard prime factorization of 480. So 48 times 10 would be a good start. 6 times 8, 2 times 3. Yeah, we ended up with prime factors here. 8 is 2 times 4, prime. 2 times 2, prime, prime. And finally 2 times 5. Okay, I'm not going to write prime factorization. I directly write standard prime factorization. How? It's easy. Let's count the number of 2's. 1, 2, 3, 4, 5. There are 5 2's, therefore 480 can be written as 2 to the power of 5. How many 3's? Just one. Therefore, it becomes times 3, and I think 1 5 is left. Okay, so when 3 and 5 have no factors, the factor, sorry, they have no exponents, the exponents must be 1. Okay, so this method says write down all the exponents that I make them blue here. These are the exponents, so we write them down in a line. So 5, 1, 1. Then we'll add 1 to each, and we write them underneath. So it becomes 6, and then 2, and then 2, and then we'll multiply them. So 6 times 2, 12 times 2, 24. Therefore, 480 has 24 factors. This is the end of this lesson. In the next lesson, we are going to start GCF and LCM of two numbers, which is a fundamental, discussion in math. So thank you for watching.